Let's look at a problem-solving application using the Pythagorean theorem. This question says, a feature wall in a garden is the shape of a trapezium with parallel sides 6.5 metres and 4.7 metres. And we can see those on our diagram. The wall is 3.2 metres high. That is the vertical height of the wall. It is to have fairy lights around the perimeter, except for the base. What length of lighting is required? So we've got quite a bit of information here. We know the length of the top side, where there will be fairy lights, but we don't know the length of these two slanted sides that also need fairy lights. So we've got a little bit of calculating to do. So I want to start here by looking at the slanted side. I know that I'm going to need to apply the Pythagorean theorem. So if I cut this shape vertically, I can see a right-angled triangle. I can see that on both sides, and because this is what we call an isosceles trapezium, where the two slanted sides are the same length, indicated by those little dashes on the sides, we know that they will be the same. So if I take the 4.7 metres away from 6.5, I'm left with 1.8 metres for the two remaining sections together. I have two of them, they're the same size. So we would calculate our first calculation was 6.5 minus the 4.7, that gave us 1.8. Then we take that 1.8, we divide it by 2 for those two little equal short sides. And so each one is 0.9 metres long. And now that we know that, we can probably draw another sketch of this little triangle on the side so we can see it clearer. So that's the little triangle formed on the sides of the trapezium. The bottom was 0.9 metres. The vertical height was 3.2 metres. We need to know that slanted side. We'll call that x. So let's label our triangle to use the Pythagorean theorem. Hypotenuse is C. The other two sides are A and B. Because we're finding the hypotenuse, we're going to use the Pythagorean theorem rearranged so that c squared is the subject and substitute our values in. Our c is x, our a is 3.2, and our b is 0.9. 3.2 squared is 10.24. 0.9 squared is 0.81. Add those together and we are left with 10.24 plus 0.81 gives us 11.05. That's our x squared, remember, and we need to find x. So we're going to take the square root of both sides, and we're left with x, not x squared, x now is equal to the square root of 11.05, which is 3.32 meters. We haven't quite finished answering our question. We found the length of that slanted side, but we know that we need fairy lights to go along the two slanted sides and that top of the wall. So the total length of fairy lights is going to be two lengths of 3.32 meters for the slanted sides, plus that 4.7 along the top. And we don't need fairy lights along the bottom, so we don't need to worry about that section. When we add those together, we are left with 11.3 meters of fairy lights altogether to go all along the wall.